In this video, we're going to talk about the sum and difference formulas and how to use them in a particular problem. So let's start with the sine function. Sine A plus B is equal to sine A cosine B plus cosine A sine B. And there's another one, sine A minus B is equal to sine A cosine B minus cosine A sine B. So make sure you know these two formulas, but let's use the first one. So let's say if we want to find the value of sine 75 degrees. How can we do that? How can we use this formula to evaluate sine 75? So you need to ask yourself, what two angles that are very common that adds to 75? Two common angles on a unit circle would be 30 and 45. 30 plus 45 adds to 75. So we're going to say A is 30 and B is 45. So this is going to be equal to sine of 30 cosine 45 plus cosine 30 times sine 45. So what's sine of 30? Sine 30 is 1/2 based on a unit circle. Cosine 45 is the square root of 2 divided by 2. Cosine 30 is square root 3 over 2, and sine 45 is root 2 over 2. So 1 times root 2 is simply root 2. 2 times 2 is 4. Radical 3 times radical 2 is square root 6, and these two will give us 4. So now we can combine this into a single fraction. So the answer is radical 2 plus radical 6 divided by 4. This is it. Now what about this one? Let's say if we want to evaluate sine of 15 degrees. What formula should we use? Should it be A plus B or A minus B? Sine 15 is the same as sine 45 minus 30. So we want to use the sine A minus B formula. So sine A minus B is equal to sine A cosine B minus cosine A sine B. So sine 45 minus 30, so A is 45, B is 30. This is equal to sine of 45 times cosine of 30 minus cosine 45 sine 30. Sine 45 is root 2 divided by 2. Cosine 30 is the square root of 3 over 2. Cosine 45 root 2 over 2, and sine 30 is 1/2. Square root 2 times the square root of 3 is the square root of 6. 2 times 2 is 4, minus root 2 over 4, so the final answer is radical 6 minus radical 2 divided by 4. So that's it. By the way, if you're not going to have access to the unit circle, it might be useful for you to know two special triangles. The 30, 60, 90 triangle and the 45, 45, 90 triangle. Across the 30 is 1, across the 60 root 3, across the 90 2. Across 45 is 1, across 90 is root 2. So let's say if you want to find sine 30, which you'll need to be able to do for these types of problems. According to SOHCAHTOA, sine is going to be equal to the opposite side. Opposite to 30 is 1 divided by hypotenuse, which is opposite to the 90-degree angle, and that's 2. So therefore sine 30 is 1 over 2. Sine 60 is going to be opposite to 60 is root 3, and the hypotenuse is 2. So it's root 3 divided by 2. Now let's say if we want to evaluate cosine 30. According to SOHCAHTOA, C-A-H, cosine is equal to the adjacent side divided by the hypotenuse. So that's root 3 over 2. Now, if we wish to evaluate, let's say, tangent 30, that's the TOA part of SOHCAHTOA. So tangent is equal to the opposite side. Opposite of 30 is 1 divided by the adjacent side. Now for tangent, you're going to have to rationalize. So once you rationalize the denominator, it's going to be root 3 over 3. That's tangent 30. Now let's use the 45 degree, the 45, 45, 90 triangle. Let's say if we want to evaluate sine 45. That's going to be opposite divided by the hypotenuse. So 1 over root 2. And if you multiply the top and bottom by root 2, it's going to be root 2 over 2. So that's where you can get these values from if you know these two triangles and if you know how to apply them. So make sure you're familiar with this expression, SOHCAHTOA. So what it means is that sine of the angle is equal to the opposite side relative to the angle divided by the hypotenuse. The CA part means that cosine theta is equal to the adjacent side divided by the hypotenuse. And tangent theta is the ratio between the opposite side and the adjacent side. Now what about cosine 7 pi divided by 12? How can we evaluate this function? What's the first thing that you would do? So first, let's convert the angle from radians to degrees. To do that, we need to multiply by 180 degrees over pi. So you want to do it in such a way that the units pi will cancel, or the terms pi. So what's 7 times 180 divided by 12? If you don't have a calculator, here's what you want to do. Let's break up 180 into 18 times 10. And 12 is 6 times 2. 18 is 6 times 3. 10 is 5 times 2. And we could cancel a 6 and a 2. 7 times 3 is 21. And 21 times 5. 20 times 5 is 100. 1 times 5 is 5. So this is about 105 degrees. So cosine 7 pi over 12 is the same as cosine 105 degrees. And 105 is the sum of two common angles, that is 60 and 45. So therefore, we need to use the formula cosine A plus B. And this is equal to cosine A, cosine B, minus, the sign is going to change. Here it's plus, but it's going to switch to minus. So it's cosine A, cosine B minus sine A, sine B. So that's going to be A is 60, B is 45. So it's cosine 60, cosine 45 minus sine 60, sine 45. Now, using the triangles that we mentioned before, we could tell that cosine 60 is 1/2. Cosine 45, root 2 over 2. Sine 60 is root 3 over 2. Sine 45, root 2 over 2. So this is root 2 over 4 minus root 6 over 4, which is root 2 minus root 6 divided by 4. So this is the answer. Let's try one more example, but using a tangent function. Go ahead and evaluate tangent pi over 12. So like before, we need to convert the angle in radians to degrees. So let's multiply by 180 divided by pi. So the pi values will cancel, and we know that 180 is 18 times 10, 12 is 6 times 2, 18 is 6 times 3, 10 is 5 times 2, so we can cancel a 6, and we can cancel a 2, leaving 3 times 5, which is 15 degrees. So tangent pi over 12 is the same as tangent 15 degrees. So we can tell that we need to use the tangent A minus B formula, because 45 minus 30 is 15. I mean, that was supposed to be a 30. So let's write the equation. Tangent A minus B is equal to tangent A minus, so this sign stays the same, minus tangent B divided by 1 plus, this sign is opposite to whatever sign you see here. So it's going to be 1 plus tangent A, tangent B. So A is 45, B is 30. So this is going to be tangent 45 minus tangent 30 divided by 1 plus tan 45, tan 30. So we mentioned earlier that tangent 30 is root 3 over 3. But what about tan 45? So let's draw the 45, 45, 90 triangle. Now let's focus on this 45. Tangent is opposite over adjacent. Opposite to that angle is 1. The adjacent side is 1. So 1 over 1 is simply 1. So tan 45 is 1. So this is equal to 1 minus root 3 divided by 3 over 1 plus 1 times root 3 over 3. So we can get rid of this one because 1 times root 3 over 3 is just root 3 over 3. Now what can we do to solve or simplify this expression? What would you do at this point? How would you simplify this complex fraction? What you need to do is multiply the top and the bottom by the common denominator of those two numbers, which is just 3. So let's distribute the 3. 3 times 1 is 3, and then minus 3 times root 3 over 3, the 3's will cancel, leaving with just root 3. And then the same thing's going to happen here. 3 times 1 is 3, and then plus root 3. Now, can we simplify this expression further? You could leave the answer like that, but let's see what happens if we multiply by the conjugate of the denominator. So since the denominator is 3 plus root 3, the conjugate is going to be 3 minus root 3. So on top we need to FOIL. 3 times 3 is 9. And then we have 3 times negative root 3, which is negative 3 root 3. And then negative root 3 times 3, which is another negative 3 root 3. And then finally, negative root 3 times negative root 3 is positive 3. Root 3 times root 3 is the square root of 9, which is 3. On the bottom, because they're conjugates, the two middle terms will cancel. 3 times 3 is 9. 3 times negative root 3 is negative 3 root 3. Positive root 3 times 3 is positive 3 root 3. And positive root 3 times negative root 3 is negative 3. So these two cancel. On the bottom, we just have 9 minus 3, which is 6. On top, we have 9 plus 3, which is 12. And we can add these two. That's going to be minus 6 root 3. So at this point, we could separate this into two fractions. So we can divide the 12 by 6 and the 6 root 3 by 6. 12 divided by 6 is equal to 2. 6 divided by 6 is 1. We could ignore the 1, so it's just going to be root 3. So this is the final answer, and it's much more simplified than the last answer that we have. So It's 2 minus root 3. So it's clear to see that the sum and difference identity with the tangent ratio is a lot more difficult to work with than the sine and cosine functions. Therefore, it's wise to try another example so you can get used to working with tangent. So try this one. Go ahead and evaluate tangent 23 pi over 12. So feel free to pause the video and work on this example. So let's begin by converting this into degrees. So let's multiply by 180 over pi. So these two will cancel, and it's going to be 23 times 18 times 10, and 12 is 6 times 2. And as we've been doing, 18 is 6 times 3, 10 is 5 times 2, and let's cancel the 6 and the 2. So now we need to multiply 23 by 3 and by 5. So 3 times 5 is 15. So we have 23 times 15. There's two ways in which we can do this. We can multiply by hand. 5 times 3 is 15. Let's carry over the 1. 2 times 5 is 10, plus 1, that's 11. Let's add a 0. 1 times 3 is 3, 1 times 2 is 2. So this is going to be 345. So we're looking for a tangent of 345. So what two angles can we use that adds up to 345? Two angles that we can use are 120 and 225. 120 plus 225 is 345. So this time we need to use the tangent A plus B formula, which is going to be tangent A plus, this side stays the same, the first one on top. So tangent A plus tangent B divided by 1 minus, the 1 on the bottom is going to be opposite to whatever we see here. So it's 1 minus tan A times tan B. So A is going to be 120, B is 225. So what's tangent 120? 120 is over here in quadrant 2 in the unicircle. So that's 120. And 180 is on the negative x-axis. So the difference between 180 and 120 is 60. So the reference angle is 60. So using the 30, 60, 90 triangle, we can find out tan 60, which will help us to calculate tan 120. So across the 30 is 1, across the 60 is root 3, across the 90 is 2. So tangent 60, opposite to 60 is root 3, adjacent is 1. So tangent is opposite over adjacent, that's root 3 over 1. So tan 60 is root 3. Now tangent is positive in quadrant 1, but it's negative in quadrant 2. So tangent 120 is therefore negative root 3. Now what about tangent 225? 225 is in quadrant 4. And therefore the reference angle, which is the angle inside the triangle between the hypotenuse and the x-axis, that angle is 45. And we know that tangent 45 is 1. Now tangent is positive in quadrant 3, so tan 225 is also positive 1. So now we can use the formula. Tan A, or tangent 120, is negative root 3. Tangent B, or tangent 225, is positive 1, divided by 1 minus tan A, which is negative root 3, times tan B, which is 1. So this is the same as 1 minus root 3, and on the bottom we have two negatives, so that's 1 plus root 3. Now, we don't have any complex fractions to deal with. All we need to do at this point is multiply the top and bottom by the denominator, or by the conjugate of the denominator, which is 1 minus root 3. So if you see a plus sign, change it to a minus sign if you want to use the conjugate. Whatever you do to the bottom, you must also do to the top. So let's FOIL the two factors on top. 1 times 1 is 1. 1 times negative root 3, that's minus root 3. And then these two will also produce minus root 3. And negative root 3 times negative root 3 is positive 3. On the bottom, the two middle terms will cancel because these two are conjugates of each other. So we only need to multiply the first two terms, 1 and 1, and the last two terms, root 3 times negative root 3, which is negative 3. So now we can add 1 plus 3. So that's 4. Negative 1 root 3 minus 1 root 3 is negative 2 root 3. And on the bottom, 1 minus 3 is negative 2. So let's write this as two separate fractions. So 4 divided by negative 2, and negative 2 root 3 divided by negative 2. So positive 4 divided by negative 2 is negative 2. And negative 2 root 3 divided by negative 2 is positive root 3. So the final answer is root 3 minus 2.